Good day, and welcome to ARC's webcast on 3D scanning. I'm your host, Antonio Cialfi, and with me today is Scott Evans. Scott is a member of the automation team at ARC. He conducts research on emerging technologies in manufacturing, such as 3D scanning, 3D printing, and modal robotics. Scott, thanks for being here today.
Thanks, Antonio. Very happy to be here.
Great, great. So Scott, tell me, could you explain a little bit about 3D scanning and how it works and what it is essentially?
Sure, I'd be happy to. So 3D scanning equipment uses non-contact technology that senses the shape of an object through the use of either laser light or structured light. Software then transforms the data collected by the hardware into an accurate, digitalized 3D representation of the object. So I'll walk you through the two primary methods of non-contact sensing, which are either laser light and structured light scanning. In laser scanning, the scanner shoots a pulse of laser light at an object and accurately measures the direction. It also senses the reflected light and then determines the distance traveled. The combination of direction and distance is used to calculate its x, y, and z coordinates for the point on the surface struck by the laser pulse. And this set of x, y, and z points is a digital representation of the object's surface, which we call a point cloud. The conversion to geometric objects then allows the addition of intelligence and higher level applications. So next, structure light 3D scanners, which are also known as white light scanners, function pretty similarly by projecting a pattern of light onto a 3D object. A camera then looks at the deformation of this light pattern on the object and calculates the distance of every point in its field of view, creating a point cloud.
So, Scott, it's basically a device for capturing a three-dimensional digital representation of a physical object. But how is this used in manufacturing?
So 3D scanning is actually used for many different manufacturing processes. At ARC, we segment the market by range, and that's because the applications for 3D scanning differ dramatically by the range the scanner is able to measure. The ranges listed on the slide here are more suggestions rather than steadfast rules for our segmentation. Short-range 3D scanning is commonly used in discrete manufacturing for part manufacturing, and these scanners perform dimensional inspection and reverse engineering applications during the discrete manufacturing process. Medium range is commonly used for designing plant upgrades with accurate as-built dimensions. In the process industries and utilities, 3D scanning provides faster completion of the plant upgrade at lower cost and is generally regarded as the most cost-effective way to capture the as-built conditions in a facility. Now, long range is a very similar set of applications compared to medium range scanning, but at ranges of up to 2,000 meters and high price tags, it's typically reserved for civil engineering and mining projects.
Well, that's great. Scott, what has ARC written on 3D scanning? And also, what sort of research have you conducted?
Sure. So ARC actually has wide domain knowledge and experience in 3D scanning. We publish in-depth market studies on the 3D scanning market since the year 2008, and we have several analysts devoted to the space. So going over these studies, they involve extensive primary research with 3D scanning suppliers, users, and integrators. And we leverage our wide range of manufacturing expertise to develop market forecasts, assess the impact of emerging technologies, and identify strategies for success in the market. We've also written a number of shorter strategy articles and views on 3D scanning. These articles introduce the technology to our member companies, explore potential applications, and offer relevant case studies.
Scott, can you help me situate 3D scanning in the greater context of asset management? And also, how should companies look at 3D scanning technology as a constituent of their asset management strategy?
Sure. So first, let's take a look at the broader look at the business processes associated with asset management. Now, models of the past have been fairly linear with a defined start and end point, but the reality of the life cycle of an asset is really more complicated than that. So first there's an initial design and build phase for a new facility. When the financial evaluation of a proposed project is approved and funded, the funded project then goes into the design and build circle. When the project is completed, there's a handover to operate and maintain. After experience with the modification, further improvements are identified, which go into the portfolio. But why is it important to have these models? And it's really because they become the framework for business process management and developing a subsequent IT strategy for application integration. The introduction of 3D scanning affects these larger business processes. And by that I mean the point cloud generated by the scanner is used in the 3D plant design software. Regular upgrades to the point cloud would provide a record of what was done. So after cement is poured, for example, the record could be used to verify that the work was actually done as specified. Some are even considering using the updated point cloud to determine progress payments. But really the key point involves the recognition of these business processes and then developing software for the workflow automation. So during the operate and maintain phase of the asset lifecycle, the plant is used to make the product and that the company sells to its customers. Some companies use a 3D model of the plant, and this usually requires conversion of the point cloud into objects which represent the equipment in the plant. Usually there's information associated with these objects. Good maintenance of these assets assures high uptime so the plant can meet production schedules. Maintenance is also needed so the equipment produces the needed quality and provides a safe environment for the operators. If an incident occurs, the 3D model provides decision support for an emergency response. It can identify the assets affected by the incident to determine needed repairs. So for example, in the case of a fire, all the valves within, say, a 20-foot radius in 3D space can be quickly identified and work orders created for their repair.
Wow. Can you provide me with a greater picture of how 3D scanning technology is used in the discrete industries?
Yeah, so adoption of this technology has occurred in the discrete industries as well, like for instance in the automotive industry and the aerospace and defense industry. We use the ARC model for manufacturing to position the two application areas. For the design of products, 3D scanning is used for reverse engineering or services sculpted by an artist. Here, an existing item is scanned, imported into design software, and modified. In very automated facilities, like in an automobile assembly line, for instance, 3D scanning can be used to inspect the parts in 3D space as components are assembled or off the line. In addition to improved quality, this enables shorter production runs and lower inventory.
Scott, can you provide me with any real-world examples?
Yeah, absolutely. And, this was actually a case that ARC wrote about a year ago. So the situation is this. Several years ago, the owner-operator of a 25-year-old offshore wellhead platform located in northwest Java in Indonesia commissioned a company called PT Synergy Engineering to reconfigure the platform and provide additional structural and other modifications to ensure safe operation over the projected lifespan. But the only available as-built drawings providing the documentation for the existing facilities was created 25 years ago when the platform was originally commissioned, but these had never been updated. On top of this, no drawings at all were available for either the piping plans or layouts or the electrical and instrument layouts, and no data sheets were available for the instrumentation. And to make matters even worse, the old equipment had no tags, making it difficult to identify during the survey. And the wellhead control panel had been modified significantly, meaning it had to be retraced to identify the control logic. Synergy Engineering and its laser scanning partner, PT Surtech Utama, applied 3D scanning technology successfully, significantly reducing required man-hours and associated costs. What they did was they used 3D scanning to support in-house design and class reviews, verify model completeness, and support client presentations. What they found was that 30 to 40% savings in the time normally required to generate an intelligent model. At this point, it's really clear that 3D scanning is the most time and cost-efficient way to document the as-built and as-maintained status of assets and to capture existing conditions.
Would you be willing to share insight from your studies?
Yeah, so we think that 3D scanning is a high-growth market in manufacturing and industry, so much so that we're forecasting over 11% growth over the next 5 years. This market really contains exceptional opportunities with rapid growth driven by both replacing older mechanical methods and also by improving workflow with lower overall project costs, which enables even more projects. Technology advances in data quality, software processing, and ease of use are rapidly expanding the applications for 3D scanners. The more effective product offerings further enhance the business benefits of 3D scanning and achieve correspondingly greater revenue. Briefly, here are some of the key growth factors and also the key inhibitors in the forecast. Driven by improved economics and capabilities, older methods for metrology and surveying, such as theodolites, are being replaced with technology using 3D scanning. And this cannibalization of older products with new technologies contributes to the rapid growth of the 3D scanning market. So hardware price erosion is both a driver and an inhibitor for the market. A scanner which might have cost more than $200,000 in the late 1990s may now even be available for under $30,000. On one hand, this has enabled the technology for a wider variety of users and verticals. However, the large increase in unit sales is paired with a correspondingly lower revenue growth. But for now, price erosion is a growth driver, but the scale may tip the other way in the future. Many of the inhibitors are the result of 3D scanning just being an emerging technology and one that alters business as usual. Customers may be completely unfamiliar with 3D scanning or may have preconceived negative perceptions of 3D scanning as too expensive and too difficult to use. Adding to this pain point, the industry is constrained by the availability of service providers. The application of technically sophisticated products provides an opportunity for service providers to have a sustainable competitive advantage, but simply put, many are just unwilling to expand their portfolios to include 3D scanning. From a big picture perspective, the drivers clearly overpower the inhibitors, which will result in high growth.
Scott, I have to say this was certainly a fantastic overview of the 3D scanning market, and I just want to say thanks for taking the time today to educate us and provide us this wonderful insight.
Thanks, Antonio. I really appreciate the opportunity as well.
And folks, thank you for listening, and that'll do it for today. Please join us next time for an upcoming webinar. Bye for now.